Get my good side on.
I got one of those too.
Oh, I just watched
Several years ago. They get potash from Saskatchewan, they park in the city yard, and of course, the cars that were built were the ones 16 in the cut.
This is the way the trade lays. That's right.
Or even
Good morning, everybody. It's getting close to 11 o'clock, so I'll go ahead and get started on everything. My name's Brian Strom, and I'm a professional speaker, or I'm a professional modeler. I'm just here to have fun like the rest of you guys. What I'd like to do is just a couple of quick house rules. If you guys got cell phones, stuff like that, if you can turn them down to kind of vibrate or low or whatever, just distract or just for the enjoyment of others, and try to keep it, especially the guys in the back over there, keep the conversation quiet so other people can hear what's going on. What I'm going to do is just a basic DCC lighting clinic, judging by the response I got from people on the internet, things like that, as we're generally in the beginning to intermediate stage. So I'm going to cover a lot of basic concepts. Those people that understand Ohm's law and all that, you can sleep through the first part of the program. But we'll go ahead and get started. Some of the things you're going to need are pretty basic stuff you normally have as a modeler. 15 watt. I recommend a low power, like a 15 watt pencil type soldering iron, because you can actually get inside plastic shells and do a little bit of soldering without melting everything. I don't recommend the gun. Stay Bright silver solder is really neat stuff, and it's really easy to work with. You can get it from most hobby shops. They get it. They can, if they don't have it, they can order it from Great Plains. Microsoft Crystal Clear, heat sinks, tape, knives, pliers, things like that. And Minitronics makes a really neat assortment of real small shrink tubing that works real well. And I have my little 1.5 volt battery tester, because I generally work with 1.5 volt bulbs. It's just easier for me. It keeps things cooler. You can use 12 volt bulbs, but sometimes they might melt, things as far as a plastic installation. Basically, the first thing I always do is sit down on a piece of paper and figure out what I want my model to do. I mean, what kind of features do you want to have on it? You want step lights, oscilloscope, blinky lights? Are you putting sound in it? I've even seen guys that have spinning fans, believe it or not, in HO. They're little pager motors, so I guess the back end stays cool, whatever. But I also, before, I do a lot of kit bashing and things like that. They do make decoders and things that'll go right in. They call them plug and play. They go right in your unit. If you buy it after, and you just slap it in there and stuff like that. But I do a lot of kit bashing, modification. I don't know, anybody got old models sitting in their closet they haven't quite built yet, that aren't plug and play. So this is kind of what I'm doing as far as the program here. I brought out one thing to make sure of. DCC does not make your locomotive run any better than it does now. So if it doesn't run good now, make all the fixes to it while you're doing an analog with the analog is just your regular old 12 volt train systems. Make sure it's running. You also might have to cut some weight, make some frames, get things to fit inside the body shell. So you want to do all that stuff early, especially if you're carving on the frame. Do that away from the motor, because all those metal shavings, they're not good for little electric motors. I can't answer this question, because which decoder is best? Everybody always asks me, and it's always the giant discussion on the internet and the magazines and everything. I've played with them all, and they all have their own features that are kind of unique to your installation. And the best thing to do is, if you know somebody that's done your particular installation, talk to them about it. Mike Kyle is way more experienced in DCC than myself. He's sitting in the back, and after we get done with this presentation, we'll open it up for questions and answers. Got a little show and tell in the front here, and Mike will go through some show and tell stuff with some different products, so you guys can kind of get a feel for what's going on here. try to get the plug in place if you can. It's the easiest way of putting things in, so I always go for the easiest route. And you'll hear a lot of, 4-function, 2-function, 6-function decoders when you're doing your decoder shop. Basically, the function is essentially a wire. So if you have one light bulb, one function. Second function, if you got 6 functions, essentially you can run 6 electrical events. Whether it be 4 sets of bulbs, 5 bulbs, things like that. FX just stands for special effects, and the FX is the stuff that's going to be your oscitrols, your strobe lights, flashing headlights, things like that. Normal decoder functions are strictly kind of an on-off. And a 6-function decoder with FX can all be 6 on-off functions if that's what you guys want to do with it. And the other thing that I found was really easy is consider wiring your lights to the track power. On the SD20, when you guys get a chance, the things that are normally on in a locomotive, at least when it's running, your step lights, your running lights, number boards, things like that, I wired that one directly to the track power. It's kind of, the resistor values and everything's the same as far as doing it through a decoder, but essentially you don't have to use that extra function. If I wanted to do that, it's only a 4-function decoder in that locomotive. For what I wanted to do there, if I ran them all to the function leads, I would have needed a 6-function decoder, which you actually didn't even have out at the time. Well, here's where the people can go to sleep for the Ohm's law and the electrical stuff, but I kind of cover the basic things. Basically, there's 2 different ways. Those are bulbs. My handwriting's not the best, but in case you read Korean, that's what it says, it's bulb. You can either wire them in series or wire them in parallel. And essentially, in series, they're kind of daisy-chained like your Christmas tree lights are. If one light pops, the whole thing pops. Well, the nice thing about that is, if the one pops, you get to save the other bulb. Wiring them in parallel is just basically twisting the ends of the wires together, essentially like you normally do. You've done on your model train sets, things like that. Going through some of the math, this was just taught to me in the hobby shop, so hopefully it's right as far as it's been working for me, is to figure out what kind of resistor you need for your particular lighting. You just have to know what the voltage is across the resistor and the current in amps going through the bulbs. Now, if you use Minitronics bulbs, they have printed right on the package the values of the bulbs. I prefer the Minitronics because you know exactly what you're getting. Some of the bulbs like MJ International, Walthers, things like that, you have no idea and you have to go through a whole bunch of testing process to figure it out. So, or you can just start with a high resistor and work your way down, things like that. To find out what the wattage or the power, or basically how hot your resistor is going to get, it's just basically the same thing, the voltage across the resistor times the current running through the system and the bulbs. So we'll start for series wiring. Basically, just determine the voltage across the resistor. You subtract the sum of the voltages from the track power. So generally, DCC systems run about 14 to 15. If you run in a club situation like we do at our club, it might even be a little bit lower because you got everybody's locomotives on there all at the same time. Might not have that kind of voltage to it. But that's all you got to do is figure out what your track voltage is, add up the voltages on the bulbs, and then just subtract it from the track power. So my voltage across the resistor, if I'm using the 2 1.5 volt bulbs, it's just basically there's the 15 volts of track power. You add the 2 light bulbs together, which is 3, and that gets you 12 volts. We're going to use a 15 milliamp bulb. That's basically just comes right from the package. It's printed on there. So here we go with just kind of an example. Let's say we've got 15 volt track power. You got 2 1.5 30 milliamp bulbs, which is normally the ones you kind of want to use for your HO scale locomotive. We basically got 12 for a voltage across the resistor to 30 milliamps, and you need about a 400 ohm resistor. Now, the values you find at Radio Shack are not necessarily going to come out even to your calculations, so generally use the one that's closest to what you're doing. Now, the power rating, if I'm talking too fast, you guys feel free to raise your hands or whatever, because I do talk fast. We get your power rating is basically, we've got the 12 volts that we figured across the resistor times the 30 milliamps, and it's 0.36 watts. So essentially what you would need is a 400 ohm, half watt resistor. You always want to go on the high side is basically the higher the wattage on the resistor, the cooler it's going to run in the model. If you went with a quarter watt resistor, it get real hot, especially if it's in plastic. You'd be smelling plastic pretty soon. Now this is the calculation for the parallel. It's a little bit different, and essentially is that you're just subtracting the one bulb. You may have 6 bulbs at 1.5 volts, but you're only getting the 1.5 of the subtraction from the bulb. So in that situation, we're using the same bulbs, but we're wiring them in parallel. You're only going to get a 1.5 volts off of it. So basically, your voltage across your resistor is going to be 13.5 volts. Now we're going back to that calculation as far as resistor. You see, the nice thing about running them in parallel using the same thing is that the amperage, forget these there. The amperage is going to be basically adding up the ratings on the bulbs. So you got two 30 milliamp bulbs. Now you've got 60 milliamps running across the resistor if you're wiring them up in parallel. So when we do our calculation, you only need a 225 ohm resistor, which is, hey, that's great. That's a lower value there. But when you go to calculating the wattage, you get 13.5 times 60 milliamps, you have 0.81 watt. So essentially what you're going to need is at least a 1 watt resistor. And I have a couple of examples of that we'll show you later. That's a pretty good sized resistor. So if you've got a small installation, you need to do, that big giant 1 watter in there, you might want to consider doing your wiring in series. The other thing nice thing about doing it in series is you've got less wires running through the unit. Because you're just going to have the 2 wires from your location. So if you're in the tail end of the unit, you've just got 2 wires coming across. If you did it in parallel, you'd have 4 wires going this way, and then you have 4 coming from the front. You got wires basically all over the place. So not a lot of space in those actual locomotives for some reason. One thing I built, I don't know if you can see once again my 3-year-old drawing skills, is I have a little resistor board. And what I use that for is basically I get close with the math, and then I use the board to kind of, with a little alligator clip, if you kind of just go run the little alligator clip, you just clip on the whatever resistor, and I test that to get the brightness of the bulbs the way I like it. If the math comes out and it's a little dull or whatever, you can always kind of, knock them up and down. I use that for testing prior to installation on a unit, just to make sure that my bulbs are running good. And don't make them too bright. That's what it looks like. I brought it's actually a little thing. It was just made out of PC board from Radio Shack, a couple of Minitronics plugs, and an alligator clip. But I think the most expensive thing was the plugs. It cost you $5 to make one. As I mentioned before, I always use the Minitronics stuff. They're really not that much more expensive than any other model manufacturer's bulb. But the nice thing about them is they get real good quality, and they have standard values printed right on the packages. So you know what you got in the bulb. And the years I've played with the stuff, they generally have been consistent to what they're advertising on the package. And then another highly scientific tool is my little 1.5 volt battery with the alligator clips, because I always make sure my bulbs are working before I stick them in the unit, close it up, and try to turn the decoder on. One thing you'll notice is even with the 1.5, and it's kind of bad from the picture here, is the top set is wired up in series, and even with a 1.5 volt battery, theoretically they should, according to the math, they shouldn't light up, but they do light up a little bit dim, so you can make sure that your solder joints are good, things like that. The bright ones on the bottom are just basically lined up in parallel. So getting started on putting them in the unit, the first thing I do is, and this is very tedious, you don't have to do this, this is just for your hardcore ribbon counter type people, is peeling the back off an MV lens. Yes, it can be done, depends on the power of your glasses. It's all I do is take a piece of tape, put a pair of tweezers over the MV lens, kind of like that, and you just pick the edge with an X-Acto knife, and essentially you'll just be able to pull the backing right off it. What it does, it gives you a nice clean lens, and a lot of guys, or at least I've seen in a hobby shop, they're drilling holes in them. It scars them up, and then the lens doesn't quite look right. When I put the lenses in first before I put the bulb, so I can see what it looks like, and I use the Microsoft Crystal Clear. It looks kind of like white glue, but the nice thing about it, it's really water soluble even when it's dry. So if you really made a mistake, you could, after it's dry, you can hit it with water and it cleans right off there. If you get the crystal clear, like say around the lens or something like that, you can actually take a paintbrush with water and touch up around the lens. It'll actually take the stuff off there. Some people use super glue, but I've glued too many lenses to my fingers. Other sides of the unit, to the cat, you know, whatever, you know, so try to stay away from that. And then once the lens is in and dry, I basically run the bulb right up to the lens, just so it's touching it. And just use my battery once again, just to make sure, you know, everything's looking good before we put the thing together. This installation, I've got a Conrail unit up here because it's going for the club. But we're just gonna, this one I've wired in series, and basically what I'm doing is just using my soldering iron. And before I, make the joint, I'm always pinning each side, putting the flux on each wire, just real quick with the soldering iron. You'll actually get a little bit of solder on them. That way, when you make the joint, you're not putting a lot of heat to the bulbs, because these real thin wires, if you're putting a lot of heat to the bulbs, or you don't use flux or something like that, you're just trying to do it with the brute force of the heat, you'll watch all the insulation start working its way up to the bulb. And you wind up with all melted wires in there. So the other thing for good strength is try to keep your bare wire part, at least the part of the joint, small. Let the insulation do the work as far as the strength. If you got real long, bare wire and it's soldered, it becomes actually pretty fragile. So as the things move around the unit or even in your installation, you could crack the wire there. And then once again, the shrink tube's going on just to keep and prevent from short. So that's basically what a series installation looks like. Is you just got two wires kind of pigtailed together, soldered together with the shrink tube on it. Here we go with the crystal clear again. Basically just slather it all over the bulb because it dries, like it says, crystal clear. I put it all over the bulb except for just the very tip, very end of the bulb, and then basically just stick it in the hole. Once it's in there, I hook it up to my batteries and just kind of move it around a little bit just to make sure the alignment of the headlights doesn't look, screwy, things like that. And then just add a little bit more crystal clear to the back. Bad thing about crystal clear, it's for patient people because once it's in there, it stays pretty tacky. You've got to really let it dry overnight. So, one night you put the bulbs in, leave it overnight, and for the next one, you come back and take care of it the next day.
I have a question.
Yeah, go ahead.
It just sounds from what you believe you're talking so far. Do you build your lighting as kind of a harness? In other words, you build a complete lighting set, if you will, and then install it sort of at one pop into the locomotive
Yeah,
cell?
that's basically.
So you don't do one by one sort of, then try to tie it all together?
Well, yeah, that's part of the early part of the planning process to save you the time. Especially when it's 1:30 in the morning, and you get the soldering iron there, you start trying to cram stuff in there. I messed up a couple of units doing that, so I really try to plan, each end, get the things, set up so I kind of have a general feel of what's going together as far as a harness. So basically, you put the decoder and just bring the wires in to meet themselves. It actually works out a little bit faster too. So that's one of the key things when I'm actually building something is to plan for the wiring ahead of time, because if you have to drill out a headlight or something like that, you've already got the unit painted, you crack the paint, or you do something, it's hard to fix on a decorated unit. Once again, DCC don't make the locomotive run any better, so before tying the decoder into it and wasting a whole bunch of time putting all these wires to everything, put it on the bench, hook it up to the power pack, and I just let them sit there, go off, watch TV, and just let them sit there. Make sure they're secure though. I've had that done where they walk off the table. But make sure the motor is truly isolated. DCC motors have to be isolated from the frame. That's why the old Ather, when they have a little tab on the bottom, that actually has to be off of there. They have to be truly isolated from the frame. And once again, just test run it. Make sure if it won't work on your power pack, your regular old 12-volt train pack, it's not going to work any better on DCC. I like to do my programming on the bench kind of with the decoder hanging loose. That's kind of the nice thing about them. They don't have to be, the decoders don't have to be actually inside the unit for you to make them do their thing. You can actually tie, the red and the black are your two power wires off your decoder. You can actually tie those in you know, a pair of alligator clips straight to your DCC system. Now, you know, my layout's about 12.5 inches long. It's sitting right up there. I brought it with me. And it's the system, a really expensive system. I only run 2 trains at the same time on that layout. But you can hook it right up and do all the programming. Make sure the decoder works, because there's occasionally quality control issues. I think all these manufacturers have suffered from them. I learned it the hard way in a beautiful PFM brass IC 7000 class, which all was really itty bitty tiny screws. It had a mystery, like you put it on the track, would flash like there's a short, you lift up one wheel, put it back on, it would work fine. Drove me nuts, and it turned out it was a quality control issue, so, but I had to take the whole unit apart, stuff like that. So I make sure the stuff works on the bench prior to throwing it into the unit. Also, once you got your decoder in, you can test your light bulbs using, you know, use the resistor board just to make sure everything's looking good there. Soldering in the resistors. What I always try to do is make sure there's somewhere resting on some form of a heat sink. Most of your trains nowadays, they come with metal weights in them. Try to put them where they're just resting on the heat sink. You know, it acts like a heat sink. Most of the time, if you're using the proper wattage on the resistor, you can pretty much hold your finger on it and it's not going to get, you know, be warm, but it's not going to be really melting anything. I always use the heat sinks when I'm soldering, because those things get really hot even with the 15-watt soldering iron. So I wind up soldering and I pick it up and go, ah, and it's stuck to my finger. So did I ever show you the scar for making GP10s? And then just do the heat shrink. So that's what it should look like at the end. That's just kind of the wire. I use plugs sometimes I don't use plugs, but this basically you're just running that resistor on one wire when you're running it in series. If you remember the diagram, one's going to be a common wire, which is your blue wire off your decoder, and then your resistors I always put on the function wire. You don't have to do it that way, it's just the way I do it. Now, basically, here comes the fun part, is connecting the bulbs to the locomotive. And one of the hardest things to guess is the wire length, because if you go too short, believe it or not, sometimes as a unit, you can't get the wires joined up or plugged together, and they just won't fit the right way when you put them in. So what I try to do is get them so they're kind of like a U shape. You know, here, like say, here's the decoder, here's your light source here, but just kind of bend it back, kind of an S shape. So that way it just kind of compacts into the unit. Makes it much easier on the installation. Watch with the space that you've got available, because I always test fit my unit. Your locomotive should all go back together the way it came from the factory. There shouldn't be any real pressure on top of the locomotive when you're putting the shell on the frame. If it is, you got to go back and move something or fix something, because what will happen is that things get hot in there, they could, you know, wind up melting your fantastic paint job. What I talked about before with the 15-watt iron is you can actually do some direct soldering. Rather than using plugs or whatever, you can actually, you know, solder things directly into the shell. You know, just have the shell kind of hanging loose. Here's your power unit, and just make all your solder joints, put it back together. I mean, the worst case scenario is you put the wires or something's not working, and then, you know, add some new wires to it. The other top secret piece of material that we use is the good old blue masking tape. Great for holding wires down, putting things into place. I generally place it over the top of the resistor, just make sure the resistor's in place. And the other thing that works real good is in the unit, if you got a couple of good wire runs in the top of the locomotive, actually use the tape and just press it in there, and it'll hold everything in the top of the locomotive, so you don't have a million wires hanging out and you're trying to put this thing, basically put this thing together. The other thing, strap wire makes really nice wire ties, because this 28 gauge wire is really tiny. You just tie a little knot around your wires and keeps things real nice, clean, organized installation in there. And basically, we're right now to the final assembly. When we put everything together, you got to be real careful around the wires. You're not pulling things out. Happens 1 in the morning, guaranteed. Here we go again. We pull the light out. We pulled something out. So basically, I just have the shell kind of sit next to the unit and just making sure everything's running real smooth, just back and forth, because you see, you can't go far on my layout. I do have a branch line, though. It's about this big. we interchange with the C&W. And make sure everything's working, the light effects are functioning, you've got the proper, your program, you get the right numbers, all that kind of stuff in there before you wind up bolting the thing together. as it should be. When you bolt it together, you put it on the track and off it goes. Now my favorite part of the whole thing is you turn the lights off in the train room and you make train noises at the workbench till the wife comes in and says, what the hell are you doing in here? You know? I spent about an hour with that SD20 the first time it happened. So. Couple things that are really good that I found off the internet. There's a Digitrax list. They kind of really only discuss Digitrax, unfortunately, but it's a really good source for information as far as lighting, wiring, complexities, things that you might run into. I belong to a DCC-friendly model train club, so I get the benefit of having all that experience running around the club. But if you don't, or you're not near a club, that's not a bad group. Of course, you can always give us a try at Illinois Central Model. We'll try to get to your questions as fast as possible. Mike Tile's on there. I think a lot of people are actually on there from time to time. And good old Mikey Tile, you can get him at Green Diamond Hobbies. I'm sure he's willing to sell you whatever you want, right, Mikey?
I don't
credit
know.
cards too, I think, right?
Oh, yeah.
Okay, that's good. And the other place is the local hobby shop. Local hobby shop is a real good place for information, general BS sessions, things like that. But I learned a lot about DCC just from guys in the hobby shop, because one thing I found from Digitrax is their instruction booklet was written for guys that build space shuttles. It's about this thick, and it needs to be 5 pages. When I found out what make train go, it can be written down in 3 pages, but they like to hide it between a lot of pages of filler on wavelengths and back EMF, and all I want to know is how do I make my train go, you know? So that's what we do. So I think we're right now at the end of our fun. We'll go ahead and turn that off, and I'll open it up to questions. Anybody got any questions? You can't tell me you got it right the first time. Yes, sir. That's going to be the next one. That's the one we're doing in the. It's scheduled to be at 12:45. Is we're going to do one on detailing Illinois Central locomotives with a heavy emphasis on chopping the nose. Because that's the question I always get is, how do you chop the nose, make it look like a Paducah Jeep? You know, everybody kind of, I think, knows how to put the lift rings in and, you know, the grab iron and stuff like that. We'll touch on those techniques briefly, but I've designed it kind of to, you know, step by step, chop at a nose. So the other thing I've done with both of these, if anybody, it's on Microsoft PowerPoint. So if you have Microsoft PowerPoint at home or office, if you want to give me your address or whatever, I can send you a copy of the CD that I use for this, or if you want, I can actually print out hard copies. I don't know how valuable the information I had up here would be to you, but at least you got some pictures, things like that. Yes, sir, you have.
A couple of basic questions.
Sure.
What do you use for the heat sink?
What I use for the heat sink? Just a little Radio Shack. You mean inside the unit or actually doing your solder work?
You refer to using heat sink.
Yeah. It's a little spring-loaded thing for 59 cents. You get them at Radio Shack. They're
You
just,
can use any kind
just
of
basic,
alligator.
anything aluminum.
Any alligator
They're basically
clips will
like
work, too.
aluminum pliers.
It's something you solder.
Just something, yeah, it's something the solder won't stick to. I think I had a picture of them here right at the beginning. I can probably bring that back up for you. But anything works. Steel tweezers get really hot fast. But the nice thing about these little spring-loaded things from Radio Shack is, you can also use them for holding stuff. Sometimes I use an extra pair of hands. Sometimes I'll use like the self-locking tweezers, just as kind of something. Have some other hands, because you can't do it with 2. If I was born with 4, I'd be a DCC master. But with 2, I got to have extra stuff. Let me get. There it is. That's basically what it looks like. That's your standard old Radio Shack heat sink. Oh, and one thing I forgot to cover is don't ever do any soldering with the wires connected to the decoder. Always make all your installations and all that, and then bring it to the decoder afterwards. Nice thing about Digitrax decoders, they actually have a bus plug that just pulls right out of there. You do all your wiring and get everything done, and then bring it back to the decoder. Yeah, sure.
I just wanted to mention, make sure that discharge yourself from any static electricity too before you touch a circuit board, just to make sure, touch metal or something, or wear one of those wristbands.
What is it now?
So, the static,
Oh, static
static
wristband?
electricity, or
Okay.
wear a wristband or touch the
You're one of
metal.
those guys who knows about Ohm's law, aren't you? Okay, that's a good, I never knew that. You know, that's why I like doing these kind of things, is because you learn stuff new from everybody. So, you can get those from what, like Minor or any electrical outfits or something like that? Good idea. Any other questions?
Question regarding, I pretty much, most of my fleet is added.
Mm-hmm.
Do you have any sort of recommendation with regard to port placement? Is it, do you have to build a weight at all, or can you sneak them in there without that?
Yeah, generally what happens with the decoders generally stay pretty, the decoder itself doesn't really get warm. The resistors can be put anywhere, you know, up in the unit. If you're using, if you do your math, like if you do like a 15 milliamp bulb, you put a half watt resistor on it, it won't get hot enough to do any damage to the unit. You can actually just stick it right in, because those Athearn units are, you know, about as thick as concrete, so you can just stick it right up in there with the masking tape. The only thing you want to make sure is that if you get the really old Athearn, you might want to take a look at a new motor just on the amperage draw. There's one thing you can do is it's a real high. They got a couple highly scientific tests. The favorite one for current testing with Digitrax, after you get through this manual like this, they tell you to put a quarter on the track. If it shorts out, it's working right. But if your motor's drawn more than like 1 amp, you just put like, you know, you put your meter on the track and just you'll have the power on and grab a hold of the flywheel so it doesn't go anywhere and see what it draws. If it's drawing more than 1 amp, you probably want to replace the motor in it so you're not looking for quarters. Yes, sir.
What's the advantage of using volt and a half bulbs with resistors versus like a 14 volt bulb?
Basically to heat the bulb. If you're running, the factory units, like a factory proto, stuff like that, what they've actually done is they put a bulb in there and they have like the plastic light bar that goes onto the headlight. And it, you know, I prefer, it looks a little more realistic when you bring the bulb actually to the casting. The 12 and 14 volt bulbs will actually run so hot that you'll actually melt the castings. Keeps the temperatures down. Anybody else? Mikey Tile.
Don't use bulbs with a current rating higher than 30 milliamp. Even if they're volt and a half, they'll still melt your shells.
That's a good one. Did everybody hear that one? Yeah. And you know, if you take a look at it, your ratings is that you go higher, it's just more heat. The higher the current running through it, the more heat you got. What's that? No higher than 30 milliamp.
15s are best, 30s are okay, but especially if you buy something that says super bright or high brights, like Circuitron has some bulbs.
Yeah.
They're really nice and bright.
The Circuitrons are good for
And
cooking food.
they throw a lot of heat. The brighter the bulb, the more heat you're going to get off of it. So,
In case anybody didn't hear, it's less than 30 milliamp and you're golden all day. Any other questions or comments?
Also,
Yes, sir.
the brighter you go, probably reduces your lamp time.
The lamp life, yeah, you're correct. The brighter you go, the less lamp light you got based on the unit. So I try to get, you know, I work like where they're really bright and work back a couple of resistors just to see, you know, it's still bright enough so it looks like the prototype, but it's not going to burn the bulb off. I think they get thousands of hours of these little minitronics, and when you put them in with the crystal clear, if you burn one, you just, you know, put some water on a crystal clear and yank one out. It's not like it's a permanent installation.
Brian, have you tried anything with the diodes?
With diodes, no, sir. You know, like I said, I have very little experience in electronics, so this was kind of stuff I picked up through the hobby shop and at the club, and it works for me. That's all I can say. But if you have some information you want to share, I'd be more than happy to listen. You know.
No, I was just curious.
Yeah, I know they use diodes for like the old Walters constant lighting units, and those got really hot. I mean, they'd actually, those you could melt down your shelf with it. So I'm just not familiar how to use it, but I know on the old constant lighting units, you know, they were getting pretty warm. Anybody else? Yeah, Dan?
Can and can,
My GP40, which I brought with me, is in a Canon cab, no problem. They're 15 milliamps in a Canon cab. Because I know they're real thin plastic. If anybody hasn't played with a Canon cab, they're really thin plastic. And but I've got a pretty, they're a little bit on the different side. So, anyone else? You can do a dimming headlight. They have I haven't ever done it. I just turn them off when opposing traffic's coming by me. So, but they do have a dimming function. I haven't tried it yet. You can actually set it up. Was it Rule 17, Terry?
Yeah, that's the headline.
Yeah.
Rule 17.
So you could do a Rule 17 if you wanted to. I've never tried it yet, but some of the guys down at Club have no courtesy. My engineers always blind when they go by. So. Especially in the night operating sessions, I can't see anything. Anybody else? If you like, we'll crack the lights back on. I have the unit that I was working on here. We can kind of, if you want to poke around on it and see what things look like, and appreciate your time. You want to go ahead and turn it back on, Dave?
Go ahead.
Start passing the money forward.
See the roof.
Just got your glasses adjusted down. Everybody ready for another one, huh? More. Well, good morning. For those of you who didn't join us earlier this morning, my name is Brian Strom. We're going to do a brief seminar on detailing IC and ICG load motors and HO scale. What I designed in project is a lot of modelers, at least a lot of people I knew were coming, are generally intermediate modelers, so they kind of know the fine-tuning parts of putting little detail parts and stuff like that. So I'm not going to get into a great amount of detail on technique because I've really kind of designed the thing focusing on chopping those Paducah noses because that seems to be the general question that everybody always winds up asking me. In case you need additional information, we do have a group on the internet. It's one of the Yahoo groups that we share emails. You can search message archives for people that have experience in modeling previous times, guys in N scale, things like that. So feel free to stop by. When I generally get started is you're grabbing the books. I'm always researching my project. Now I'm not what's known as a ribbon counter or whatever, but I kind of really like to work by looking at a picture. It's easier for me, especially back when I was getting started when I was a kid. I didn't know what was what on a locomotive, but I knew what that thingy on the side was and went through my catalog and attached it to it. So what I do when I get started is I just briefly take out a sheet of paper and write down what I'm planning on doing. What details am I going to put on it? What details am I going to leave off of it? Put together my shopping list. And as we covered in the DCC lighting clinic, even back in the days before DCC, you still want to kind of have lights in it. So part of your construction plan should always be, if you're planning on lighting it, is making room and making the necessary modifications so that you can actually stick the lights in it. I've never really happened to prove my modeling was, I don't care if I mess up anymore. For some reason, I don't care what this thing looks like, it comes out great. But then when I'm always concentrating real hard on it, a lot of these things, your shells and things, they have replacement parts now. Yeah, it's expensive at $20 to get a new shell, but my approach has always been, hey, if I mess it up, big deal, I can always do another one. And the other thing is, it's your railroad, have it fun, do it your way. This is not designed as the only one and only way of modeling the IC. Everybody, one part about model railroading is basically doing it all the same here. Of course, you got, where you're shopping for parts. I prefer the local hobby shop because I can get my hands on things and actually look at them. Walter's website's a good one. And of course, jump on the Yahoo groups to find out, people's previous experiences. So. And the other thing really is to stick to your plan. When you start trying to make modifications in the middle or trying to do things and kind of, you might wind up with using those highly technical terms that are generally in 4 letters. So That's an IC unit, so that's kind of my starting point, is you've got arrows all over the place. Some of these things, they make commercially, some of these things they don't. I was gonna do this as a quiz, but I didn't have enough time to do it, but you know, you're looking at pieces of the locomotive. You know, many people at model aren't really railroaders, and they don't know what this thingy is called, but they know what it looks like. You know, your folding pockets, your toilet door, your horns, you know, this is a little thingy that keeps the door open from slapping around, bells. You know, you're just generally, when you're sitting down with your plan going, well, I want to do this, I kind of want to make it look like that, and just to get the overall feel of the locomotive. A lot of things, you know, on the IC rebuilds, and there's discussion, not everyone's different, but, you know, changing the louvers around is probably one of the toughest things to do in HO modeling. I haven't really found a good, successful way of doing it. It's very tedious, so I just leave them alone, and I find a model that's close enough for government cheese, and just basically kind of go from there. Same general hobby tools, make sure your X-Acto knives are sharp. I got this one from a dull X-Acto knife at about 2 in the morning, 7 stitches. So that was a GP10. We used to have to saw through those big old athers. They're about 2 foot thick. So tweezers, sandpaper. Generally, I like to use the K&S stuff because it's really fine grit and it got good control on it. It's really nice stuff. You can wet sand it. It's got a plastic backing, so it's real easy to use. And the other neat thing that you can find is the flexi files. I don't know, I hope I put a picture, but if I didn't, they almost look like little abrasive things like, you know, kind of women are doing with their nails, but they come in a bunch of different grits, and they're like a plastic with a foam, so you can kind of get around the curved surfaces. You can actually cut them a little bit, so you can get into your tight corners and things like that for doing your sanding. I prefer for plastic work the Ambroid Pro Weld. That pretty much will melt everything. So all different kinds of plastics, I've used that stuff on. The other thing is your CA type glues, your super glues as they like to call them. I prefer the Carl Goldberg Super Jet and Slow Jet. I've been using this stuff for years. And like I said, this is just the way I do it. It's not necessarily the best way or the fastest. But this stuff's been real consistent. And I always apply it with some scrap wire and just the old part, you know, the plastic bags, the detail parts come in. You just put a little drop of glue on that, use the wire to make the applications. As far as for body fillers, you got the Squadron Green, and believe it or not, that's not a typo, it's actually called Mr. Surfacer. It comes from Japan, we'll cover that in a little bit, but that's what they call it. And the other thing is just to have plenty of good light in your workspace. I have enough light generally, you know, with all the light bulbs, it raises the temperature of the room about 20 degrees. And the wife's always complaining, why don't you turn the air conditioner down? Well, that's so I'm not sweating in the hobby room there. So, things that generally the process of what I do first. So I'm going to do all the chopping and the hacking on the shell before putting the detail parts, obviously. So if I make a mistake, I don't have $30 worth of detail parts going down the tubes. Fit the shell to the drive. We're going to be covering the Proto 2000, front range makes a shell, but if you're going to actually reduce the nose, you might have to make some modifications to the weight, or what you're doing might actually have to make some modifications to the frame area. So I like to get that out of the way first, because it's the messiest. It's easy to do it when the shell is kind of, you know, in its rare form before all the detail parts are going on it. Make sure that's working. Throw your detail parts on, paint it, decal it, weather it, finish it however you want. And the other thing, I don't know if everybody's aware of them, they're not all that expensive, is Reeboks. A lot of your hobby shops can order them for you. They're basically the boxes that look like they come from brass units. But if you spend a lot of time, and I like the proto boxes, you can't ever get anything in there. Once you've built something, it's kind of hard to put it back in there. So the Reeboks are really great for protecting your work. I've got some samples I can show you, but basically the foam, you just pull out the little, they're serrated, and just drop your stuff right in there for protection. So, all right, getting started on the Jeep. The easy part is the cab front, because Cascade and Pacific, I've got their website down there. There's also a link on the group to them. Currently, they're out of stock, but they're going to be going back into production soon, so you can double check with their website. It's an easy solution for the cab front. So that's one of the easiest things to do. It's just basically stick it in there, glue it in there. You've got your headlight. Particular unit I'm doing had the Ocetrol in it, which is an overlay casting, and kind of throw that stuff on there. I've seen guys use the Proto 2000 GP18 caps. putting the window fronts in them, that's an idea. The one thing I forgot to put on here is Displains Hobbies, and Displains, Illinois makes a plastic window insert for IC Paducah rebuilds. The other thing that, this is not necessarily you have to do it, it's once again going back to the rivet counting, is getting the battery boxes and the steps moved around, just, you know, so that they're actually matching the prototype. A lot of the stuff I do is just because I'm a sick puppy and I like to do it. You don't necessarily have to do all this stuff. You're definitely going to have to do the cab front though, because otherwise the local engineer won't be able to see where he's going. Starting on the chopping process, there's a plate and some, nice thing about the protos, there's not any details up there, but there's an actual riveted plate that's on the top of the nose. So the first thing I do before I even start cutting is get that plate sanded off there. I'm using 150 grit sandpaper on that. Then I'll come back and remove the headlight casting, get rid of the steps that are on there. And then the other thing that takes a little bit of work, but there's actually 3 access doors on the side that those will need to come off. So you just basically take them off, be patient with your small files, and then just finish it up with the sandpaper. If anybody has any specific questions, like we're on a certain thing, you know, feel free to stop me or throw something at me if I'm not looking at you before we get going. Here's the scary part, making the first hack. What I like to do is take the sections and use the top part of the nose and the bottom part, and then remove the middle portion. So I'm working my way back to those lines. So what I'm going to do is my first cut, and I'm just using a handsaw. I don't even have the handle in it. I'm just moving it with my hand is to cut that nose portion up. Make sure you got plenty of room to spare, so you got plenty of room to work. Don't use the Dremel tool, especially if it's your first time. Your second time using the Dremel tool, you already know that the Dremel saws, things like that, will actually melt the shell and booger it up. So next one, I have my cut lines marked with a pencil. I also have my lines where kind of where I'm going to be at my finish point. So I have a visual clue where I'm working myself down to, so I'm not. It kind of helps me avoid making mistakes. And of course, we already covered using that fine-tooth saw. I start with the finish process is once again the 150 grit paper, getting the nose portion, the top part of the nose portion, flat and level. You can see it kind of down at the bottom. I have, fortunately, a friend of mine managed to pick up some 5/8" thick glass, which is a great work surface. But you may want to make sure you're working on something that is really flat, pieces of steel, piece of glass, something like that. And then what I'm doing is I'm just removing the material that just under the classification lights, which you can see down in the corner. And then I'm always kind of checking to make sure that it's straight and level on the glass, so they don't have it kind of going this way or that way. Doesn't matter if it's absolutely positively perfect, because that's what they invented putty for. The other thing is don't press too hard when you're sanding. Just be patient. That's one of those things where you don't care, just because if you try to get it all in one pass, that's generally when you wind up scarring things up. It's one of those things, if you cut it twice, it's still going to be too short. So you don't have, once you get gone too far, it's time to go order up another nose. The bottom line is pretty much the same process. I do remove some of the middle material that's left over. They make these rail cutting pliers or on pliers or a fine set of side dikes or whatever. You get rid of that middle material, and once again just finishing it up, putting it on the glass to make sure that everything's running level. And then here comes the test fit. What you're ideally trying to do, or at least what I'm trying to do when I put these things together, is that there's not a lot of gap going around the nose portion. Also checking with how it fits in with the rest of the body to see how that's working, so that really when you're applying your liquid glue, you're really joining the two surfaces together tightly. That's how your finish wants to be. You want to make it nice and smooth, because that saves you a lot of sanding, a lot of puttying, and a lot of extra work that's involved. I prepare the bottom with just a couple of pieces of 15 thousandths evergreen styrene, sticking it on the inside, so it's, number one, it's got some strength, because I've actually worked on one that I didn't do it that way and snapped the whole thing off after I got it painted. So all these techniques were discovered by ugly mistakes. So I'm going to use the Ambroid Pro Weld and then basically join the two sections, being real careful that to keep the alignment, because when you free that nose, it kind of wants to wiggle a little bit, things like that. Finishing around the edges, you can see where I added the extra 15 thousandths. And one thing you want to be careful with this liquid glue, if you haven't used it before, is it runs just like water. So if you have your fingers on the outside of your works material, it'll actually run in there and you'll just make a giant imprint of your fingers into plastic, which is a real pain to be sanding out of there. I prefer squadron green. There's other kind of putties out in the market. It's just stuff that works best for me. And I go around and fill what areas of my, on this particular one I got lucky. I didn't really have to do much in the joint, but there's actually some recessed lines that go around the nose. I wind up just, basically slapping on as like you would if you're working in a body shop. When I come to take the stuff back off, I'm using the 320 grit. Just got it in the sink, just working it. Wet sanding for some reason seems to work a little faster and also get a real nice smooth finish. I do have the unit up here for later, so we can kind of use that for the show and tell. Here's old Mr. Surfacer. I don't know if it's poisonous or toxic because all the instructions on it are in Japanese, but you can find it at your better model shops. It's really was stuff that was designed for the plastic model guys. Most of the railroad shops, you go, you got any Mr. Surfacer? You go, what? But the stuff really is nice. It's kind of almost like thick paint. So if you got like those thin cracks and things like that, it fills them up real nice. And the other thing is that squadron green putty, and a lot of those putties are still a little bit porous. And if you've ever, I don't know if some people have done this in the past, when you paint that squadron green, sometimes you'll actually see the line where the squadron green was because it was kind of porous. What the Mr. Surfacer will do is actually seals that stuff up and it makes a real hard, smooth, flat surface, which is really easy to sand. You want to sand in between each coat, and you don't want to really build it up. You just kind of want to flow it. If it doesn't get it all, let it dry, sand it out, and come back and do it again. It takes probably, I don't know, a couple hours to dry, so it's something you can kind of do a couple times during the day. And once again, the 320 on the wet sand. Adding the frog eye casting. Thanks to Mike Tile at Green Diamond Hobbies, we now have bought several of the Overland castings for the frog eye. It's not quite 100% perfect, but it's the closest thing we can find. And of course, can contact Mike at his website there. And I believe you have some available.
Yes, sir.
If necessary, you can pick those up. All I do is just basically start making a hole with like a number 76 drill bit, working it. So I got a hole big enough to stick my casting in. I've drilled out the casting. You don't have to do it unless you're running lights, but I've drilled out the casting so that I can stick some lights in there. You want to be real careful and take your time so that once again the joint is tight, so you're not having to do a lot of sanding because it's kind of a complex curve, so it's kind of really hard to get the putty and all that kind of stuff in there. And then once you got that thing installed, I go to what I call the final surface finishing. I'm just kind of filling in the cracks, sanding up the basic nose. I filled in, there's some holes that were on the top for lift eyes. There was some horn, of course, when it was a high hood, it had a horn on it. There's a hole for a horn. I take the remaining, you can see that little green spot, that was what was left over the hole from the headlight, and I just basically clip off the plastic lens, the clear plastic lens that they used, that there was in there. And I stick it in the hole and glue it so that way it's, just needs a little bit of putty to finish it off. So I've just got it sanded out using my Mr. Surfacer. You want to be real careful around the edges and corners because you actually change the shape of the nose, which makes it kind of hard to line things up later. This one little trick someone showed me is basically the easiest way that I found to put grab iron, put your grab irons on and drill your holes without trying to hold the thing and try to write on a pencil on that little itty bitty nose. So I take a piece of tape, stick it on my glass, draw my lines, and then stick it on the model and basically go ahead with my number 80 and drill the holes there. For some strange reason, the way I built that nose, at least on this one, the holes that were in the factory holes were perfect. So that was just on there for show because generally I have to do that, but for some crazy reason, it doesn't happen all the time, but the holes all lined up. I called Dave Frederick just to double check because we had to get a GP10 down in Effingham. It's about 18 to 19 inches spacing on those grab irons. and it does fluctuate with each unit, so 1-2 inches in HO scale is, you know, minutia. Working back with the CA, I want to cover this a little bit. We talked about it. You know, some people are afraid of the stuff because they wind up sticking their fingers to their head. You know, I've done that plenty of times before. But basically, all I do is there's that plastic bag thing from a piece of the whole detail part I've already used, and I just got some scrap brass wire. Now, the finer the wire you use, the more control you got over the glue. So if you're doing fine installation, I have like a 15 thousandths piece of wire. You're just slapping it on to put something, you know, some big parts together. You know, 25, 30 thousandths piece of wire. Sticks work good, things like that. One of the things I always try to do is, if I've got to glue something with the super glue, is try to glue it from the inside of the model. When you get the stuff on the surface, there's nothing that I'm aware of, unless someone knows better, that takes super glue off the plastic from the outside that won't actually harm the plastic. So you want to try and keep it all on the inside of the model. For small little excesses, you know, if you got some coming out of grab iron that's making a puddle or something like that, newsprint, notebook paper, you can kind of just, you know, tear yourself a rough edge and you kind of just go like right by it and it'll pick it up. Don't make a second pass because that's the one that smears it all over the model.
You know what works real good for that, Brian, is they sell those little glue wands.
Yeah.
I don't use those to put glue on, I use them to soak up my mistakes.
They look like miniature Q-tips, right?
Yeah, and they're very, the reason I don't use them to put glue on is because they hold so much glue. You put them in the glue and it soaks, but they're really good if you make a mistake and it, you know, flukes out, because I'm real bad with the grabs, especially on one. Just stick it in there and it wicks it right out of there.
Yeah, that's a good idea. I haven't tried that yet, so that's an excellent idea. One thing I discovered by accident is, believe it or not, those handy wipes they pass out to you in the restaurant, they actually took super glue off my fingers. Now, it was only Superjet at the time. I was down at the club and got glue all over my fingers, went out for some chicken wings, and started cleaning my hands, and all the glue started coming with it. I don't know if it was the sauce or the chicken wings or the glue. I'm pretty sure it was the handy wipes. The other thing, if you really got them stuck together, the nail polish remover with acetone, which is getting harder and harder to find because my wife prefers the non-acetone stuff, which is the stinky. And I go, well, get the other stinky stuff. Well, why? Well, so I have to get my fingers apart. And then, best way to correct for excess super glue is to sand it. Don't put the acetone on there. It's just going to wind up melting plastic. Here we go. We've got it pretty much sanded, finished up. We're working on some of the fine details. What I do is, being rivet counter, I got to add rivets. So I actually add the nut bolt castings on top of the grab irons by basically pushing them all the way into the model and just sticking my drill above the top of them, because what happens if you try to do it without the grab iron in the hole, a lot of times your drill will walk on you, or you might drill through the same hole and it's kind of messy. So I push them all the way back, drill my holes, then I use the 40 thousandths plastic. It seems to give me a good looking space. I'll move the nut bolt castings in with the liquid glue first, and then Superjet for the grab irons. And once again, we're gluing from the inside. I didn't add it on there, but the other thing I'll do is, once they're all dry and they're set up real well, I'll go back in the back of the model with the Xuron pliers or your small clipper and clip all the grab irons off there. I've tried doing it by shortening them up and put them in first. They just seem to go all over the place, so I just put them in long and cut them. If you don't cut them, then once again, that's interference with your drivetrain. You'll have a hard time putting the thing back together. This is for only the sickest of puppies, is putting the toilet door in. The Paducahs, as we had on the first, slide with the Jeep pen, they have a door that's in the side that's for the toilet door access. If you like, there is a little bit of a gap down by the stairs. You just take 40 thousandths plastic and no one will make any fun of you. But if you really want to go at it, mark the opening of the door. I'm using the Cannon door on it. I use a number 76 drill, which I'll show you here in just a second, is to perforate it so it looks like a postage stamp. I'm on the inside of the door. I've leaving myself plenty of room to work back to the material to make the space, but I'm just basically punching a bunch of holes. So when I clean that material out of there, clean it out just lightly with an X-Acto knife, it'll come out of there like a postage stamp. I've tried other saws, stuff like that, and for some reason they just keep going too far. Or since you've already got that nose all put together, know, when you're sawing or working it, you might crack some of the joints that you've just worked so hard to sand out. And then placing it on a flat surface when you're cutting it out so you don't crack that nose again. Here's the door, using Canon's HD 1004 door. Basically cut a notch in it to clear the steps. Also removing just a little bit on the bottom of the door so the hinges and everything will look correct and they'll fit the space. And then you can see the perforations. First I take out the perforations, then I start working the flat file close to my pencil marks. My pencil marks are actually a little bit inside the door as well, but that way it starts telling me when I'm in the danger zone where I gotta start working real carefully. And I'm just gonna finish it out with that flexi file just to make sure that I'm close. And I don't take it all the way to perfect yet because I wait to install it actually on the model because it's a lot easier to work with. So I'm gonna wind up gluing the nose and everything to the frame, and then I'm gonna finish out that opening for the door so that it'll fit flush and then the nose has had a chance to flex or do whatever it's gonna do when you're putting it back on the model, so then the door will fit correctly. No second chances, so once again, you go too far, you can't, I haven't found a way to really fill in or fit the door. I'm gonna tack it from the inside using that Ambroid Pro Weld, and then I'll just take a bead, a very light bead around the outside to kind of seal up the door. Those Canon doors are real thin, so if you use too much plastic glue, it'll actually start oozing out of the side and actually deforming those doors. And yeah, don't squeeze the door. If you see some glue or whatever, just let it all dry first. If you squeeze it, it'll form like a little bead and it'll look like somebody went up there and tried to tack both the door shut so the guy couldn't get out. That's basically it. Then I'm just going to go and finish up some of my fine details. So we're back again to our question and answer session. Hopefully I got answers for your questions. So, anyone? They all went to sleep on me. All right.
I got a quick one, Brian.
What's it? Yeah, Dave.
Your pencil line, when you make your first cut, I mean, I probably the question probably a lot of people's minds is how far down from the bottom of the windshield should you get your final product when you have the top of the hood? I mean, is it more of just kind of what looks good, or do you actually measure up from the walkway so many millimeters, or you see what I'm saying? When you make your first cut.
Okay. Yeah, it's a logic thing, and I forgot to really put it into it. I understand. If I'm understanding you right, you need to know how much material you're moving from one side or the other. Okay. And then if you remember the first slide, basically what I do is I can't go any farther on the top to give it a good joint because the headlight casting's in the way, you got the poles and everything. So I just take the top of it flush with the bottom of the class light. Okay, I know what that's a constant measurement. Then the bottom piece, I'll test fit, I'll remove, I kind of eyeball it when you got too much on there. It used to be a highlight. So I'll remove kind of eyeball to get it, at least so it'll slide underneath the headlight casting on the top there, the number boards. And then I'll just kind of slowly start taking it down with the top on it. So that you really pretty much eyeball it. And HO, you can measure it, but the problem is that things start moving around, especially when a shell's free from the. So I just kind of eyeball it and really slowly get it close and just take it in. So it's just basically the top part is flat. You finish it out flat. You just start taking the material out of the middle until it gets close to do your final finishing. Anyone else? Yeah.
One thing we were talking about this morning, some of you guys that are maybe intimidated by trying something like this, don't get discouraged if your first attempt is not what you think is contest quality. Brian can tell you, anybody else who's kit bashed these, the more you do, the more tricks you learn, the more tips you pick up on. So it's like you said earlier, I mean, worst case scenario, you just order a new nose and order some new parts and start back again. But the main thing is to keep working, keep practicing, get the hang of it.
Exactly. I forgot to bring it. I brought my first one, which is the one that cost me this part of my thumb. That thing is so ugly. But I was proud of it at the time. I was 15 and having a good time. Anybody else? Lauren or anyone? No?
Just ask real quick,
Yeah,
Brian. So you're using just a plain saw blade, just to get the flat, because I've done a couple myself, and I always end up kind of getting a little bit of a curve.
I'm going right through like the middle of it.
Yeah,
I'm just making the first cuts with the saw blade,
alright.
okay, and the saw gets put away. And then I use they're like rail nipper pliers, you know, to get a good flat flush cut. I also have some RC car scissors they sell too, and I'll just go around and just nibble it
Okay.
until I get it
So you get
close.
flash and glass.
Yeah, until I get it close. And then I'll come in with my file. The other thing that I've done that I forgot to mention is you can actually turn your X-Acto knife into a plane. Normally people, when they're shaving down, they're kind of going, you know, they're going this way, and they're cutting into material and they're going like this, right? If you turn the blade opposite, you know, you're still going the same, you know, it's like this, but you're pulling it back like so, it'll actually kind of work as a plane. And I find that gives me a real good straight edge, at least for kind of making material early. Yeah, Chad?
One thing that'll also help for some of you that may not like using the solid hacksaw, because I'll be covering some of it tomorrow in scale, the seminar there, but the small jeweler's hacksaws that are out there, you can get a really, really precise cut using that. Again, using your pencil marks, as long as you go around slowly, and especially if you're looking for a small seam, that'll sure give you an advantage over the regular blade that you show on there earlier. So it's preference in what you feel comfortable using.
Where are those typically available?
The little jeweler's hacksaws, I got them at the wall.
Yeah, I think X-Acto makes them. Micro Mark tools on the web is great for all those little model tools, stuff like that. They've got all those neat little tweezers, pliers, magnetic holding things, stuff like that. Once again, I make the offer. If you want to leave an email address or whatever, I can make a copy of the CD or print copy for you if you wanted a copy of it, because I know I kind of blew things through quickly. We're always loving to talk about chopping Paducah nose on the group, so beginners are always welcome, and we generally learn more by having 20 guys discussing it, just like you mentioned. You know, we always wind up learning something new every time, and you know, since this is kind of my first time doing these at ICHS conventions, I kind of was going to open up the floor to see what do you want to see done next as far as a model thing for next year, you know?
SD20.
SD20? You don't mind if I jump off a 15-story building instead, right? Yeah. It's the rapid deceleration that gets you.
Come on, it's just SD48.
And I appreciate your time and listening to me and letting me talk. I know sometimes I talk too fast, but the real ones or the model ones?
Actually, you can get away with two of them being slope nose.
You can do whatever you, well, they weren't always straight on the real thing. So I figure if I'm off a little bit, if they're theoretically supposed to be flat across the top. You know, poor for drainage, obviously, or theoretically flat across the top. But I've seen a lot of units. I know SD20 2018 has a very visible crank to it, where it's a lot lower on the fireman side than it is on the engineer side. If you really start looking at it, I mean, you know, basically you'll find them. Yeah, there's not much fore and aft. They're usually pretty flat as a tabletop across the top there.
And if some of you are wondering, I guess I misunderstood the question he was asking, but if you want to use a lifelike nose, maybe, you know, if you want to do something a little bit different, you have the slope nose. You did have a couple of Paducah Jeeps that did use the EMD slope nose for GPA 10. So you reference it. And look them up, you'll know what road numbers to look for.
Was it 8418?
8418, 8461.
Now, for the battery boxes and the step modification, does that involve removal of material from the photo sub-base?
Yeah, basically you remove the sub-base, kind of the same. I use the same method, you know, I'm drilling it out with a small drill. Anytime I take material away, rather than go at it with a saw or like that, I postage stamp it and then come in and clean the stuff out. You can do that, you know, door replacement with Canon doors, like if you're going to do like the GP38AC or, you know, an SD48 where they have the sight glass in there. The easiest way, of course, is just to drill the sight glass in and finish it, but if you want to really do the door, you can do that kind of same stuff for removing material. This month's Model Railroad Craftsman's got a really good article on kit fashion, an SD38 using Canon doors. Gave me a lot of ideas for an SD20 if you, as far as for scratching up. I don't know, Chad, it looks like you saw and seen that article too. So Anything else? Okay, well, I'm done. I'll leave, wanna kick the lights on. Dave? Got the shell up here if you guys kinda wanna poke around, take a look at it, we'll answer, you know, questions, things like that. And, I believe our, next seminar with Don Horn will, start at 2 o'clock.